We are back with the Mac. Today we're having another look at the Mac Classic 2 that we started to look at before. If you recall, we looked at the main CPU board and we found that we had a problem with the CPU having its pins stoved in. I've now got a new CPU that we can put on there. We got most of the analog power supply board recapped, but we were missing this one big capacitor. I've now got that. We can get this one fitted chunk like that, and that will be good to go. I've also got a new battery to go in here, and then hopefully we'll be able to see if we can get it to work. So let's do it. Now, I also noticed that this capacitor here got missed, and that is, looking on the chart, that is 1 microfarad 50 volts. And I happen to have some of these. They are not the same brand. These ones are Worth. This is Rubicon, but we have that value. So I'm going to be putting one of those in, and here it is. Positive goes this end. We will call it the black sheep, because it is, well, it won't be the only black capacitor on there, but one of a few. And then the final capacitor, this one, and it goes in this way around. Yep, stripe to the wall. There we go. It takes a little while for the solder to melt, but that's okay. Just let it flow. Let it flow. We were gonna solder it anyway. And there we go. We can now think about putting the shield back on the back. Because it's always good to have the shield on the back, and we've got our little plastic study things. So they're just push fit. Much easier to put back than they were to take out. And it's in. So that's done. I'd like to thank PCBWay for sponsoring this video. PCBWay are well known for making printed circuit boards. Whether it's your own design or whether it's a shared project that somebody else has designed, you can get boards from just $5 for 10 boards. But they don't just do PCBs, they also do 3D printing, they do CNC machining, they do sheet metal work. They are also running their 7th annual design contest. It's not just for electronic projects, it's also for mechanical projects and STM32 projects this year. There's a top prize of $1,500 plus extra bits and $6,000 total prize money. So what are you waiting for? Get your entry in. And while you're there, check them out, www.pcbway.com. Now back to the video. So now we should be able to put the analog board back. I think it should be a matter of simply sliding it onto this rail. Kind of like that. So we need to plug that back into there, doing it very carefully. This goes into here. And that just slides on. And I believe we have a screw to put in there. So that goes on there. It goes in there, but we need to push it with a screwdriver. There we go, and this is going to go back onto here. Let's screw this on first. There we go. And we can keep that safe in the case, and that will be good. Right, we can keep that to one side and know that it will be safe. So the job is to get this off. I'm going to use hot air to do that. But the first thing that I want to do is remove this capacitor because it is going to be in the way. Then hopefully we can put it back afterwards. So I apologize if you don't see some of this. Okay, so what I'm going to do is put aluminium tape around here, and I'm then going to heat it with the hot air gun. The aluminium tape is to protect everything else, because unlike Kapton tape, this will actually deflect the heat. I'm going to take that chip out actually. There we go, a little bit over that. There we go, that should hopefully protect the components. I'm just going to heat this up until we can actually remove the chip. Okay, what I'll do is I'll try adding some flux and see if that actually helps. There we go. Let's turn the heat on again. There we go. I've removed the tape, so we just need to clean it up now. Some IPA, fresh bottle. Yeah. Oh, that explains it. Goopy glue that was actually holding it down. So there, it's clean. Not too worried about the chip itself. And we'll clean it and it will go in my dead chips bin. Because that was not pleasant. I don't like the way they put cling film on it. Partly because you can never find the opening. Whoops. It fell out. There it is. So that is going to go in there. Already I see there are some pins buckled, so we're going to have to address that. Right, time will pass. Okay, hopefully this is going to work. I have got, just so you can see, microscope, PCB. Here is my laptop which is recording the microscope. Unfortunately with this one, this is a replacement device, it doesn't show on the monitor as well as on OBS. So I've got OBS stretched to full screen. And you can see, hopefully that is going to record what we do. And here is the board. So we are going to try and fit this 68030. Here it is. Now, there are some pins that are slightly bent, so we may have to adjust those. And since my previous attempts with the microscope and SMD soldering, I have got a thing of Chip Quick. So hopefully that is going to go a lot better. So let's try and position this. Okay, it goes this way round. Let's see if we can get it lined up. It seems lined up. This end pin is going to cause us a problem. Because you can see it's bent. Okay, I think that might be it. Ah, no, that pin. Hopefully that's it. So that looks okay. That looks okay. It's not quite flat. Some of those pins are definitely bent. I do have some more of these 68030s on order. I suppose I could wait and see if those actually are better. Because that's okay at this end, but it's a bit off on some of these pins here, this one and this one. I'm going to talk to some people. I've been fiddling about with that for the best part of an hour, and to be honest, every time you touch it, something moves out, so it doesn't stay in position for any period of time. So what I think I'm going to try is putting the flux on and then positioning it. I'm going to squirt flux to the top. Yeah, that's not even going on the thing. So what I'll do is I'll take the chip off and then put flux on the board and put the chip back on the board. Pardon my flux gun farting. And of course I'm going to be right in front of the camera. Here comes the chip. Right, so we're one pad over. Doesn't look too bad that side. That doesn't look too bad at the top either. Okay, I think that is pretty close. So what I'm going to do, load some solder onto the iron. Ah, bugger. Ah, shit. That completely screwed it. Right. I'm going to go for this bottom corner here because I think the soldering iron will get in easier. Right. Solder on the iron, finger on the chip. I'm not worried about bridges. Some more solder on the iron. Now I'm going to go round to the opposite corner. Okay, that's firm, so what I'm going to do is put some solder on the iron. It's maybe not the best tip, but it's the one we've got. I'll come back to worrying about that. I'm sure you're going to be cringing in your keyboards, but this is my first time doing one of these, so I'm going to try the opposite direction. It's sort of on. Right, now we've got some cleaning up to do and some pins that are not in the right place. Gonna give it one last go because you knew I would, right? So you can see this is a horrible mess. It's got loads of gunked flux on it because I haven't bothered to clean it since I'm going to take it off. I'm going to get some of those pins kind of working, but this pin here is sort of come off. I think it's vaguely over there. We shall try and find it. That's A10, so it's not like it's unimportant. But yeah, some of those are connected quite nicely, a lot of them are not. So what I'm going to do is I'm going to put some flux on here and then get this chip off. This is just to help it. And then I've got some fresh chips. Which you can see they've got nice clean straight pins, so that'll be really useful. Hopefully they will work a lot better. So let us get at it. It'll probably be noisy, so bear with it. I'm just going to go around the chip, letting the flux melt, and then hopefully the solder will melt. I've got aluminium foil around to protect the other chips. Starting to lift. There we go, it's off. I think we can see that trace is actually still there. We can just possibly straighten that out and fit to it. Okay, so now I'm going to let this cool and clean this off, and then we can have a look and see where we are. So I've cleaned the flux off the board, and now I'm about to put some more on. So what I'm going to do is just put some flux on the row of tracks. And then I've got some solder flux wick, and what I'm going to do is I'm going to dip that into my flux. A tip I got from the Mr. SolderFix channel. I would highly recommend you watch that. I'll put a link in the description so you can find it. And then find my solder. This is, doesn't say it, but it's supposed to be lead. I'm not convinced. So put some solder on the iron, then with this tip fluxed. No, it's not doing it. It's not doing it. I'm not convinced that's very good solder. It was sold to me as leaded, but I think, to be honest, like all the other times I've bought leaded solder, it's a total con, and they've sold me lead free. So I'm going to go back to my trusty 1.2 millimeter. People tell you to use 0.2 millimeters or 0.5 millimeters or something on these, but oh yeah, you see that melts so much easier. Get some solder on the tip. Maybe that's where we went wrong before. No, that's still not doing it for me. I think this is... I'm going to change the tip on the iron. Okay, we'll try some of this solder. I've put a different tip on the iron. It's not the one they recommend, it's the chunky one, but it's one that I'm comfortable with, so that counts for something. I'm going to use this flux and try some of this on the solder wick. Because maybe that liquid flux was too liquid. Okay, and some of our thick chunky solder. The idea is you add solder to get the flux, to get the solder flowing. That got part way. Okay, I think that worked. I'm going to go through the others. Okay, I think that's got it. So I'm going to clean the board again. And now it's time to get a CPU out. So very carefully. It's almost there. Just not at the top. Oh, too far. That's right, that's right. That's right. Yep, that looks like it's it. That's it. So there's a little blob there and a little blob at the top. And then hopefully it's got two pins, but never mind. Turning it round. Now I'm just going to try almost dry soldering this. But not. There's some bridges there, but I'm a lot happier with that than I think I was before. So let's try it again. I'm basically just going up to the edge of the pins, not going over them at all. And watching the flux melt underneath. And I'm hoping that those are going to hold. We shall check in a bit once I've gone around the whole thing. I'm just touching the very tip of the iron onto the solder, melting barely 0.5 millimeter. This is why I kept this foil on, because the iron would otherwise melt the plastic. See, it's getting better, I think. Although I can't tell how well those joints are going. I'm not used to looking somewhere different to where the work is. So I'm probably getting some of these pins twice. And others possibly none at all. One of the problems I had before was with solder bridges near the top. That's because I was trying to sort of drag. Oh, let's get rid of that one. That looked like it might have not got attached. There we go. Okay, I think that looks connected. Nothing on that side is loose. Nothing on that side is loose. I think we've still got one short there though. That's better. No, those haven't made contact. So we're going to have to try those again. Okay, that one right in front of there is also, I think that's the last one that appears to bounce. That looks pretty good for me. Don't worry about that. That's repair in progress. It's been epoxied down. There's a big blob of solder on the top of it for the time being. Right. Going to clean it up and then do some continuity tests, and hopefully we can then progress. Yeah. See you in a bit. What I didn't do before I put this back in was test the voltages. So we're going to take it out again. So we have our analog board, and what we are also going to want is the hard drive. We want the hard drive in order to have a load on the power supply. That way we can measure it properly. We're also going to need to look at the floppy drive before we finally get it going. Because the eject mechanisms are a bit notorious. Okay, that's the hard drive. We'll move this out of the way because we don't need it for the time being. There we go, then that won't get damaged. Now this is a Quantum. Interesting, there's no screws on that side. 40 megabytes. It's got a little sticker on it. That doesn't particularly matter. What we just need is to plug this in. Like that. Now my understanding is that if there is no motherboard attached, then the high voltage stuff does not take place, but I'm going to stick some tape over it just in case. That way we can't touch it. There is a little pot down there which should adjust the 12 volts voltage, and from that we can work out the 5 volts voltage, or at least it works out the 5 volts voltage. And I'm going to measure it on the drive connector. Okay, that is plugged in, but it's switched off at the socket. So what I'm going to do is switch it on here and then switch it on at the socket. And hopefully it's not going to go bang. Right. Are we ready? I can hear the hard drive spinning, that's a good sign. So it's spun up and it's spun down. Now we should be able to measure from in here to in here. And that should be 12 volts, it's 11.63. And this should be 5 volts. And it's 4.93. And we want to twist this until we get 12 volts. That's going the wrong way. It's definitely going the wrong way. 0.04. Or 11.96. What does that give us on the 5 volts? 5.07, that's about right. Okay, so that is our 12 volt rail and our 5 volt rail set up, and we've tested those and checked them and they are fine. I've stuck this capacitor back on. You've seen capacitors go on before, it didn't really need to show that. So before we can plug this in, we need to go through and check it for shorts. So what I'm going to do is go through with the multimeter. I've got some nice fine needle probes, which hopefully will let me check each pin, and we shall let's turn it onto beeping mode. And that should let us check whether there are any shorts. So let's go along this row. Before we hook this back up, we are going to check the power supply voltages, just to make sure that nothing is short-circuited. So this is not, there we go, this is not a regular sort of ATX style power connector. There is plus and minus 12 volts on here, but there is also, and 5 volts, but there is also a whole load of other signals. So we've got VSync, HSync, video out, sound, and a modulated brightness control. These bottom 5 pins are ground, so they're all connected together. Then these 2 end pins are plus and minus 12 volts. So we can just check that they're not shorted to each other and they're not shorted to ground. So there's a, yeah, that's about 8 megohms between there and there, and that is about 8 megohms between there and there. And then these 2 pins are 5 volts. So we'll just turn that back on to beep. And they are connected together, but they are also not connected to ground. And they are not connected to 12 volts. That's good. These are VSync and HSync. And then this is video output. This is sound output. And then that's minus 12 volts. This is the brightness level. Again, not connected to anything else. So, okay, that's fine. So I guess this is the moment of truth. So this is a ATX extension cable, which is 24 pins or 24 wires, but this is only a 14 wire extension. So several of these pins are basically not used, the black ones essentially, but that still goes as per. I haven't plugged the hard drive and the floppy drive in at the moment, partly because I don't have an extension ribbon cable for them. But what I'm going to do is turn on the Mac at the back, and this is currently not powered because the plug is switched off. So in order to see what is going to happen, I'm going to switch the plug on. So here we go. 3, 2, 1. I haven't tried this. So far, nothing. Oh wait, here comes a picture. It's not very bright, but there is definitely a picture, and that is more or less what we had before. Just not very bright. It may be my imagination, but that does seem to be fading. Okay. Turn it off. So I don't know what that could be. I'm going to have to go and do some reading. After reading the service manual, on the back of the machine there are these knobs on the analog board, and they are from top to bottom: horizontal size, vertical size, contrast, focus, brightness, and horizontal center. So we should be able to adjust those and get the picture working. Brightness is the second one up from the bottom, so I've got a plastic tool, and I can't see the picture and the yoke, so I'm going to have to sort of do this at a funny angle. Let it warm up for a bit. Different pattern. I can't tell what. Ah, there we go. So that's got a picture. Now, could it just be that the display has collapsed in? The top knob is horizontal size. No, it isn't. Well, that's interesting. That's different to what we had before. I'm going to have to go away and research this, because although that's different to what I previously had, it still kind of suggests this is a Mac that needs recapping. And it's been recapped. But is that the analog board or is that the logic board? I think that's all I can do for this video, so thank you for watching, and please check out my Patreon if you want to support the channel. My current patrons are scrolling up the screen, and I look forward to seeing you next time. Hopefully we're going to be able to continue this and get it working. So tune in. See you next time. Bye.